Let's have a look into the atmosphere at altitudes from 80 to about 1,000 kilometers. Here we almost have vacuum. You know that the International Space Station and lots of satellites are flying there. So less than 0.01% of the air mass is there. And this little fraction of air gets partially ionized by solar irradiance. So we have permanently plasma in this region, and this plasma is what we call ionosphere. It's a tracer gas, so that means the densities are low compared to the normal neutral gas. But still, this plasma has a very high importance because it's impacting radio wave propagation. This is used for HF communication and also for navigation applications with global satellite navigation systems. During perturbations in the ionosphere, these applications can be severely impacted by the ionosphere. The ionosphere has variability that depends on the variability of the solar irradiance, that depends on the solar wind. It also depends on the atmosphere conditions. And that's why we get periodic changes that can be in periods with hours to periods of decades. And because the ionosphere has an electromagnetic coupling, then also the geomagnetic field is impacted, and that's why we see these ionosphere periodicities also in the ground spectrum. So the plasma in the ionosphere is not only produced by solar irradiance, also particle precipitation plays an important role, especially in the auroral region. These particles that are precipitated there come from the magnetosphere. Especially during substorms, this magnetosphere plasma gets accelerated and injected into the Earth's atmosphere. And there it collides with the neutral particles. And due to this collision, then we get ionization and excitation of the particles, which is accompanied by the emission of light. And this is what we see as aurora. You know that it can have different colors, and the colors depend on which particles are included in the collision and at which altitude. The occurrence of aurora depends on the solar activity. So we see solar activity periodicities also in the aurora, and this also feeds back into the geomagnetic variability, and we see it in the ground spectrum.